Y'all see how there's this QR code in the corner? Scan it real quick with your phone, and then your phone will be invisible after that. I just want you to see what I'm giving you each time. So on your notes, every single notes that we do, unless somehow we forget, will have the same QR code on there. Those of you who got it open, what is it linked to? YouTube. Guess what? That's my YouTube channel. I record all of the lectures that we do, and I put them in this playlist, which means that if you go home, you're like, wow, I literally forgot everything. You can scan that QR code or go to Google Classroom, go to my link, and you can re-watch the lecture or just maybe the part that you don't remember or understand, and then you can be able to do your homework and understand this class. So that's going to be there for you every single time we do a notes. It's also linked in your Google Classroom. Okay, your phones can be put away now. Thank you for scanning that. Please put them all the way away. Phone, backpack, pocket. So the first topic for geometry that we're going to go over feels really basic because we got to start at the basics of shapes. The basics of shapes are three things: points, lines, and planes. Not airplanes, but geometrical planes. So let's start at the very beginning with a coordinate point. A point is a location. Location. So it's a place in space. It has no size and it has no shape. We represent it as a dot because how else would we represent it? It has 0 dimensions. The way that we indicate that we are talking about a shape is with a capital letter. Oh, that's the wrong capital. Embarrassing. Capital letter. So for example, like you have printed on your paper, you have a little dot with a capital A next to it. That's point A. So we could write that as point A or just simply point A. Those indicate that we're talking about a coordinate point in space or on a coordinate grid or just in space in general, a point. A line is officially defined to be an object made up of at least 2 points that extends indefinitely in both directions, in opposite directions. We're going to use both of those words. The main point here is that it extends indefinitely. So if you notice something about the line that's drawn here, what do you notice that are at the ends of the line that is drawn on your paper? Arrows. I'm going to be so picky. If you do not put arrows at the end of what you are intending to be a line, it is no longer a line. It is something else in geometry, and I'll tell you what that is in a little bit. So they have to have the arrows at the end to be a line. Some more vocabulary we're going to go over is the word collinear. Collinear points are points that lie on the same line. So if you have line L and A and B are on L, then they are collinear. But a line itself, through any 2 points, there is exactly one line. Again, represented with 2 arrows. It has no thickness or width, because it's just a line. We have to draw it with a certain thickness or width because we're using pencil to indicate a line. And it has 1 dimension. It is named by a lowercase letter or 2 points that are on the line. So for our picture that's on our notes here, we could call it line L, and they're usually going to be in cursive. At least for me, I'm probably going to draw them in cursive, the letters, so line L. Or you could call it line AB. Or you can use the symbol AB with a straight up line with arrows on top of it to indicate that line. So however you want to call the line, that's great. You're going to have line L, lowercase, probably cursive for me. Line AB, since A and B are both on that line, or the symbol AB with a straight up line and arrows on top of it. That's how we talk about a line. The third object is a plane, or the third vocabulary word on this side of the page is a plane. A plane is a flat surface that extends in all directions. Coplanar points, kind of like collinear, are points that lie on the same plane. When we draw this on a flat 2D piece of paper, we are representing it by a parallelogram, like you see next to the word plane, because it has 2 dimensions. It's going to have 2 dimensions, kind of like a surface. It is named again by capital letters or 3 non-collinear points on the plane. Now, one thing I need to make a note of, when we talk about the capital letter, it cannot be a point. So if there was a point called A on your plane, you cannot call it plane A because that's just straight up confusing. So make sure you use a letter that is not used anywhere else. So for example, the plane that you see on your page can be called plane M. It can be called plane ABC, since those are 3 coordinate points, 3 points on that plane, or any combination of A, B, and C. So you could say BAC, ACB, ACAB, however you want to say it. Okay, so we've gone through 3 examples, or 3 definitions right now, and those 3 definitions were also on your card sort that we did at the beginning of class. Look through the 3 stacks you have for point, line, and plane. I want to see if you want to maybe move some things around right now. So look through your card sort. Point, line, plane. See if you want to change anything. If we come down to these practice questions down here, it's really going to be about naming stuff correctly because that's super important in geometry, especially because I'm going to start calling things by their proper names. And if we don't know what I'm talking about, then we're straight up lost. So we're going to use this image here, and we're going to name different things for this image. For number 1, part A says give all the other names for, and then it has ST with a line on top of it. Is that talking about a point, a line, or a plane? A line. Don't highlight this because we're going to be highlighting all over the place, but I'm going to highlight the section I'm talking about. I'm talking about this line ST. See the dots S and the dots T and how there's a line with arrows specifically that goes in between them? There are some other names for that line. Can we figure out what the other names are? Remember, with a line, we can also call it by a lowercase letter. Is there a lowercase letter up there that's kind of the same as S and T? M. So we can also call it line M, because line M is another name for line ST. Here's one we might not think about, so I'll give this one to you. We have line ST, but order doesn't really matter with a line because those 2 points are still on it. So we can call it line TS, switch the letters. It's still indicating the same place in space. Do you also notice that there is another point that's on that line? What other point that I highlighted it purple is on the purple line? I heard somebody say it. Line or point P is also on that line. So they are collinear, which means we could also call ST the line PS or the line PT.
What do you notice that she draws every time on the top of it?
That's so important. You'll see why when we get to the back of the notes, but that's so important that they have arrows. Okay, there are a whole bunch of other ways we could name this because we could say line, like straight up the word line TS, line PS, line PT, switch all those things around. There's a lot of names for lines. As long as it has points on it and you're using those points, then you're good. Part B says give all the names for plane R. Now when we're talking about plane R, this time we're talking about all of this. To indicate a plane, we're going to use a capital letter, which they did. Okay, check. They talked about plane R. The other thing we can do is we can use 3 non-collinear points. A non-collinear point would be like S, T, and V. Do you see how they aren't all connected? Like they kind of make like a triangle if we were looking at this flat. Those are things we can use to name the plane R. So let's call it plane VST. We can also reorder those letters. So it could be plane SVT, plain TVS, plain STV. However we want to use those three letters, as long as they are non-collinear, which means they sort of make a triangle instead of a line, then they're great to use as name of a plane. Is that clear? Okay, the next one asks you to name 3 points that are collinear. What did the word collinear mean? Do we remember? They're on the same line. Is there any 3 points that are on the same line? Which ones? SP and they're capital letters. T. So when we do this, we need to call them points. So we're going to straight up write there on the word point S, point T, and point P. Those are the 3 points that are collinear, meaning they are on the same line. They don't make a triangle. Non-collinear means make a triangle. Collinear means make a line. Part D says name 4 points that are coplanar. What did coplanar mean? They're on the same plane. So which 4 points up there, I keep saying coordinate points, which 4 points are on the same plane? It's very similar to your last answer. Ooh, remember, R is not a point. R is the name of the plane. See how there's no dot right next to it? R will not be a point. But all the rest of the points that we essentially see, like point V, point S, point T, and point P are coplanar. Now, there is a coordinate point that I did not put on this list. What coordinate point did I not put on that list that we see in the image? Q. Now, do you notice that Q is kind of like jutting upwards? Is that on the same flat plane as S, V, P, and T? No, it would be like 3D coming at you. So when it's 3D like that, coming off of the plane or intersecting the plane, then they are not coplanar because they're not on the same flat surface. Okay, now our turn to draw some images. In part A of number 2, it says draw the image being described. Sketch plane T with the line OP in the plane. Here are the things I know. I know that when I'm talking about a plane, it needs to be a parallelogram. So here's my plane T. That's a parallelogram. Check. Parallelograms indicate planes for us. But it also says that line OP is in the plane. So what should I do with the letters O and P? Put them on the plane. Here's O, here's P, and what should be going between them? A line. What does this line have to have on the end or else it's wrong? Arrows. So if we have a line in the plane, then our image simply needs to have the line in the plane. Does that check out? Does that make sense? Okay. Part B says that we want to sketch line TX and line C intersecting at point Q. What does the word intersecting mean? Crossing, yeah. So what we need to do is we need to have TX. So here's my T and here's my X. That's a line. Line TX. We're also going to call it, we also need a line C. And I'm going to draw my line C kind of looking like this. This is going to be line C. And it says they're intersecting at point Q. So that place where they cross, I should put a dot there and call it what? Q. So now we've seen intersecting lines. In part B of number 2, we now have an additional word from our card sort that says intersecting lines. You notice there are 2 lines that cross. I think most of us got the intersecting lines part pretty good. So I don't think we really need to resort anything. But if you want to resort something real fast that does not intersect or have 2 lines that are intersecting, that would be great. On the back side here, we have 3 more vocabulary words to go over for today. On the top here, a line segment is defined to be simply a part of a line that connects 2 endpoints. It consists of the two endpoints and all of the points in between them, and can be divided into multiple parts, so we can kind of like add line segments together. It is named kind of like a line by the two endpoints. However, since it is not a line, it is a line segment with no arrows. Instead of putting arrows on top of A and B, I'm just going to put a flat line. That's why it's so important that if you mean line, you put arrows. And if you mean line segment, you don't put arrows, because it stops. So these have to stop. Do we see that? Line segment, no arrows. Line has arrows. We can also just straight up call it, like with words, line segment, AB. That's another appropriate way to talk about it, but that's a lot of words. I'm going to use the symbol a lot. So AB with a line, no arrows, means line segment. This also means that line segments do not go on forever. They have ending points. Speaking of ending points, though, a ray is an interesting geometrical shape. A ray is a part of a line again, but this time it only has one endpoint and extends for forever in one direction. It is represented by a line with one arrow. So if we look at the image right here for the ray, we have two different rays. See how it has an endpoint on one side and an arrow on the other? That's a ray. The way that we name it, this is important. Order totally matters here. We start with the first endpoint and then the other point on the ray. So if we were talking about this one, does it start at A or at B? A. So when we talk about it, we would say ray AB. Ray AB. Notice this time that when I use the shorthand with the symbol, there's only one arrow on top, indicating that it is a ray. Do we see that? Yeah? And I'm not going to write this necessarily down because I think it might confuse us to have it. How would you change the name if I were talking about this ray? Would it still be ray AB? It would be BA, because we start at the end point, go towards the arrow. So that would be ray BA. That is important. The order matters with a ray. Now, opposite rays are two rays that share a common endpoint, but extend in opposite directions. Each ray is named individually, but they are written with the shared endpoint first, because again, order matters. Now, what does an opposite ray kind of look like that's on the other side of this page? Starts with an L. It kind of looks like a line, but we're talking about different things here because when we talk about a line, we can use any letters that are on that line to describe it. But for this one, we'd have to say ray CB and ray CA. Do you see how I put C first for both of them? So it's like a ray that starts here and goes this way, and a ray that starts here and goes that way. Those are opposite rays. If point B lies between line AC, then BA and BC are opposite rays. That's the textbook definition of it. But I think it's easy to see in a picture that they kind of make a line when you put them at the same endpoint because they are opposite rays. So we're going to do the same thing. This is the same image actually as the front side as number 1, but we're going to continue to name stuff. The first question says, give another name for ST. Now this time, is this a line or a line segment? Does it have arrows on top of ST? No arrows, so it is a line segment. So the ways we can rename this is we could just, again, switch those letters, segment TS, or we can use words, segment ST segment TS. For line segments and lines, the order of the letters does not matter. But what does matter is for our rays. Part B says identify all of the rays in the diagram. If I get you started, I think you might be able to find all the rest of them. There are 3 rays in this diagram. One of the rays that I see is right here, from P to T. So we're going to say ray PT. Can someone tell me another ray? M, that's actually a great point. Thank you for saying that. M is a lowercase letter. So that's talking about the name of a line, but thank you for doing that. So lowercase letters are lines, not points. So let's try another one. What other ones are kind of have a ray going between them? Oh, I heard PQ. Love that one. It's coming off the screen. And PS. Heard that one. It's coming back towards us. So as long as it has an endpoint and is extending in one direction through another point, we can call it a ray. There are 2 more rays that we might not notice. That is ray ST and ray TS. Because technically those are both rays. If you have ST, it still starts at one point, goes through T, and extends in one direction. So that is still a ray. But if we go a step further and we want to just name a pair of opposite rays, which one of the ones that we wrote down on part B are opposite of each other? So they need to be opposite of each other and start at the same point. So which ones up there that we listed start with the same letter and go in opposite directions? SP, ST. Those are started with the same endpoint, but they go in the same direction. We need them to go in opposite direction. Say again? PS and which other one? Okay, that one's going to work. So if we have PS and PT, if we go look at our image, we got them starting at the right point, which the one with the S was a good idea because there's PT and here's PS. Do those go in opposite directions? Great, then they are opposite rays. So not only do they have to start with the same point and be a ray and go through the same points, but they have to start at the same one and go opposite directions. It's a whole lot of things. Part D says name 3 points that are not coplanar. 3 points that are not coplanar could be, it's the same question as the front, isn't it? Oh, that are coplanar. So if we say not coplanar, we could say that not coplanar is point S, point T, and point Q. Why are those not coplanar? Specifically the Q part. Is Q on that parallelogram? No, it's like coming out of the parallelogram. So that's not on the same plane. So it says not coplanar. Coplanar means they're on the same surface, on the same flat image. So see how Q is like coming out of it? If this was an index card, Q would be on like a pencil stuck in the index card coming out of it, not on the index card itself.
But T and S is in the same thing, isn't it?
They are, but all 3 of them together are not coplanar. So S and T are coplanar because they're on the index card, but Q is like coming out of it. So the 3 of them together are not coplanar. That's a great question. Part 4, number 4 says draw the image as being described. So it's our turn to draw. It says sketch plane X intersecting ray OR point O with HL outside the plane. Oh my goodness, that's a lot. Let's start at the beginning. It says sketch plane X. How do you indicate that it's a plane? What's the shape that you use to show that it's a plane? The flat thing. It's called a parallelogram. Yeah, that one. There's our plane, and we're going to call it X. That is plane X. Check. It says that it's intersecting, which means crossing, with the ray OR at point O. So if I need it to cross, that means I need point O to be on the plane, and I need the ray, OR, to be extending out of the plane. Because it's just intersecting. It's not on the plane, it says intersecting with the plane. And then it says this, I'm not saying what it is on purpose, outside the plane. Is that a line or a line segment? Line segment. And if it's outside the plane, that just means it literally can't be on the plane. So I'm going to draw mine like way over here. Here's HL. Pretend that line is straight. That's so embarrassing. That's a curvy line. But if it's outside the plane, then that just means it literally can't be on the plane. So boom, I drew it off of the plane. So the directional words are going to be very important in this class when you draw your own images. Intersecting means cross. Outside means off of, not touching at all. Those different things. Now we have just one more definition, which we've kind of gotten to for some of them. Intersecting figures are when two geometric figures intersect or cross when they have one of more points in common. The intersection of the figures is the set of the points the figures have in common. So if you notice, when you have two lines and they cross each other, where do they cross? What does it make when they cross?
Intersecting point.
A point. So two lines cross at a point. We've known that since geometry or algebra when you found the place where two lines cross. But what happens if you take two planes, two parallelograms, and you cross them? It makes a line, which is really, really interesting, that the intersecting planes create lines. Now, I'm sure you're doing a little bit of the, why is this important? If you build anything, this is important. There are intersecting planes all over this classroom. If you look at the corners of the walls, you have a wall that's flat this direction, and you have a wall that's flat for our ceiling. When they meet in the corner, does it make a point or does it make a line? A line. Those are intersecting planes, the floor and the wall. Intersecting planes which create a line. The floor, the crease of the floor. So we've gone over a lot of vocabulary here. I think we might be able to readjust some of our stuff now that we've gone over some more vocabulary, specifically like the rays and the opposite rays. Could you please look through all of your card sort right now and maybe change some things up now that we've seen the different vocabulary words?